Okay, so what we're going to actually be doing tonight as well is you should have just finished watching 5.3, which is about trig proofs, which we can also continue tomorrow. But we're also going to be going over a few new identities. So what I'm going to do right now is just introduce to you what some of these new identities are, and then we're going to save all of the examples for in class tomorrow. So we're just going to do right now what these new identities are so that you have some sort of reference and you can add these to your list. So the first thing that we have are cofunctions. Now, you might not have heard of these as cofunctions, but you actually did something with cofunctions back in Math 2, and it might help if you can see what I'm talking about. And so when you were in Math 2, when you were first learning sine, cosine, and tangent, we would have triangle ABC, and we would pick an angle A, and I'm going to call that my theta, and we would have little a is across from big A, little b is across from big B, and little c is across from big C. So if we were going to do sine of angle A, so sine of theta, we would say it's A over C. Cosine of theta would be B over C, and tangent of theta would equal A over B. So this is just going back to your beginning trig in Math 2. Now, what if we have this other angle theta? Okay, theta I'm going to put where B is. If I were to do sine of alpha, sorry, not beta, alpha. If I were to do sine of alpha, that would be B over C. Cosine of alpha would be A over C. And tangent of alpha would be B over A. Well, what we have here, what I want to point out to you, is if you notice how sine of theta and cosine of alpha gave us the same ratio, as well as cosine of theta and sine of alpha gives us the same ratio. Well, what you want to point out, or what I want to point out, is how alpha and theta have to add up to 90, making them complementary angles. So what we're going to be looking at today are called complementary cofunctions. Because sine of alpha and cosine of theta have the same ratio, these are considered cofunctions. And so that's what we're going to be looking at today, are properties dealing with cofunctions. Functions that have similar ratios depending on the angle itself. So, for example, our cofunction identity for sine would be, if I were to take sine of an angle x, it's going to be the same as cosine of 90 degrees minus x. So that's how we would find its complement, doing 90 minus x, which is exactly the same as what we would do here. 90 minus theta would give us alpha, and so those would be the same, sine and cosine. It also goes the other way. Cosine x would equal sine of 90 minus x, because it works the other way. If I were to do cosine of alpha, that would be the same as sine of theta, where theta is its complement, so 90 minus theta would give me my new angle. Okay, so this is kind of the picture example of how sine and cosine are cofunctions. But we also have the reciprocals of sine and cosine that are also cofunctions. So we also will have secant of x will be the same as cosecant of 90 degrees minus x. And then these also can flip as cosecant of x is equal to 90 minus x. So sine and cosine, as well as their reciprocals, are cofunctions. Now all that leaves is tangent. Now tangent is not necessarily a cofunction with another tangent, it's actually cofunction with its reciprocal. Because if I were to make this a cotangent of theta and flip this as well, I'd have the same ratio. So our last one is tangent of x is going to be the same as cotangent of 90 minus x. And cotangent of x is equal to tangent of 90 degrees minus x. So these here are called our complementary cofunctions. They're angles that are complementary but that also produce the same ratio, but it does allow us to change something from a sine to a cosine if necessary when simplifying, or from a tangent to a cotangent, or anything like that. The other thing that we're going to look at today, besides cofunctions, is we're going to be looking at what it means to be even and odd. So just like numbers, functions can be even and odd. And so I know you guys did this a little bit last year with graphing. We're going to do a little bit now, and we're going to do a lot more when we get to graphing next semester. And so when we think of even and odd in terms of our sine graph, so a sine graph starts at 0 and it comes up and around, but if we continue it the other way, oops, let's extend that. So we have this continual function. A cosine graph starts high, goes low, ends high, and if we continued it in the other direction, we'd have a second period there. So what does it mean to be even and odd? It means that it's if you can make it into a reflection. So if I were to put a mirror right here on the y-axis, do I have a reflection? Because on a cosine I do, I have a reflection where this point will map to the same distance on the other side. This is what makes an even function, is when you have that mirroring effect on your graph. Algebraically, it's going to look like when you were to, whoops, I didn't mean y. What it means is that if you were to plug in, let's say f of x equals a number, or yeah, let's do f of x equals a y, f of the opposite of x will equal that same y. So this is what it looks like algebraically to be even, is that whether you plug in x or its opposite, you're ending up at the same y value. Now odd doesn't have this mirroring effect at y. It actually has more of a mirroring effect about the origin or the diagonal y equals x. So if you were to take an x value here, and so if this is x and go negative x, you would have the exact opposite of what your first one was. So for an odd function, if you were to plug in x, you'd get a y. But if you plug in the opposite of x, you would end up getting the opposite of y out as your answer. That's what makes something odd. So even would be plugging in positive or negative, it won't matter, you'll get the same y value. For odd, plugging in positive or negative will give you exact opposite answers. So when we think about these in relation to our trig functions, because that's what we're worrying about right now. We'll do even and odd with other functions later. But for even and odd right now, a cosine of negative x will equal cosine of x. The negative won't matter. They're going to always equal each other. This is why cosine is even. But for the other one, sine is odd. So we would say sine of negative x is going to be the exact opposite of the sine of x. So the negative comes to the front, meaning I have my y value here is going to be the negative y value that I got when I plugged in x. Now tangent graphs are also odd. They have the same kind of mirroring that a sine does. So we would say tangent of negative x equals negative tangent of x. So these here are examples of odd, and cosine is even. So what we're going to be doing in class tomorrow is 3 examples where we're going to still do a proof. We're still going to be verifying and doing trig proofs, but we might have some complementary cofunctions in there, as well as the need for even or odd in our problems. So these are just more identities that you're going to need to have known by the time the test comes around to be able to use.